Okay, so today we're going to keep talking about radicals. We did a bunch of stuff with radicals last class. Today we talk about roots and radicals as well as these things called rational exponents. Remember, a rational number is a fraction like 3/7. So we're going to see what it means to have a fractional power. What does it mean to take 2 and raise it to the 3/7? Coming up still a little bit on the distant horizon, quest number 3, which is on April 8th, which I think is a week from Wednesday. Questions on anything? Somebody emailed me over the weekend, said they were having trouble accessing my math lab this weekend. Did anybody get in this weekend? Yeah, okay, no problems. All right. Okay, so we'll start at the top of page 115, and once a few more folks come in, I'll talk about this policy change on the board. Irene, summary? Okay. Good. Jeremy, number 1. Nth root of x to the k. Okay, so this is something that we saw last time, and I'll just give you a quick example to remind you. If you saw this, remember what we're supposed to do with the 3 and the 12? We divide. Which one on top? When we divide? 3/12 or 12/3? 12/3, right? So we saw this last time. That's equal to x to the 4th, yes? Okay, so every example that we saw last time, we made sure that we had a number that went evenly into the top number, right? 3 goes evenly into 12. But it turns out you can use that property, you can use this division idea, even if the number in the bottom doesn't go evenly into the number on top. So for example, this 5th root of x to the 8th is really x to the 8/5, which is the same division property we saw last time. It just doesn't go in evenly. Right? Is everybody okay with that? So really there's only one way to go wrong here when you're converting between this radical and this exponent or the other direction, and that's to get the 5 and the 8 in the wrong spots. And so there's these little mnemonic devices. Again, I don't know if it's going to be helpful, but we'll just share them just to make sure you know which one goes on top. So it says the index goes below deck. The index, remember, is the little 5 in this case, the number in front. So the 5 goes below. Index below deck kind of sounds similar. And then flowers grow up and powers go up. So the power is 8 in this case, and it goes up on top of that fraction, right? So you just got to make sure you know whether it's 8/5 or 5/8. Okay, so go ahead and try number 3 right now. Rewrite the following in exponential form. 11th root of -2y to the 13. So we're writing that as something to a fractional power. Make sure we get the 13 and 11 in the right spots. (115). Okay, so we'll start with this -2y. Make sure it's in parentheses. It was in parentheses before. It still needs to be there. Is it 11/13 or 13/11? 1 vote for 13/11. Other votes? Okay, so just make sure we put it in the right order. So that's going from a radical to an exponent, but I also need you to be able to go the other direction. So in number 4, I'm giving you an exponent, and I want you to convert that to a radical. So x to the 2/7. Take a moment and write that as a radical of some kind. Okay, what number goes in the front here as the index? That's a 7, and then where does the 2 go? It's right above the x. So that's the 7th root of x squared. Everybody okay going that other direction? Questions on that? Okay, let's try number 5. We'll go to Christian. Okay, so the first one is 64 to the half, 64 to the 1/2. So this is a radical of some kind. 64 goes underneath here. Again, what's the index, the little number in the front? 2. And then what do we do with that 1? We don't need to write it, but if we were going to write it, where would we put it? Is on the exponent, right? 64 to the first power. Okay, so apparently 64 to the 1/2 just means square root of 64 to the first. How much is that? 8. Right? That's just the square root of 64. Yeah, so if we have numbers, then we want to clean them up as best we can. Okay, what that also means is that if you see a 1/2 as a power, it just means square root, right? This problem is just the square root of 64. So with a little bit of practice, we start to make these kind of shortcuts, these associations. You see 1/2 as a power, at some point it's just going to be immediate. Oh, that's just the square root. Okay, part B is the same thing, but there's a negative in there. So let's try that one. So this is equal to negative 64 here. Again, where does the 2 go? In the front, and the 1 is the power. So this problem is asking for the square root of negative 64. What do we think about that? Is it 8? So if it were 8, then 8 times 8 should be negative 64. But 8 times 8 is positive 64. So it can't be 8. Negative 8 seems like a good thing to try. How much is negative 8 times negative 8? Is again positive 64. Yeah, Tyler. Absolute value of 8. Yeah, I mean, there's something happening here with this plus and this minus, right? So you got to give just one answer. I mean, you can't, not allowed to give 2 answers.
It's like negative 8 times.
Yeah, it's negative 8 times 8, but that is not what a square root means, right? Square root is very specific. It says, give me the same number times itself to build, in this case, a negative 64. And at the moment, it's just not possible, right? It's because if you multiply a number by itself, it's either a positive times a positive or a negative times a negative. But either way, what kind of answer do we get? Whether you do a positive times a positive or a negative times a negative is a positive answer. And so it feels like at the moment, we're stuck. There's just no way to build a negative 64 when I square something. Yeah, so I'm gonna write this. I'm not gonna write can't be simplified. I'm gonna write not a real number. We can't take the square root of a negative number. But later on this semester, we will learn how to take the square root of a negative number. So this is like a temporary answer at the moment. Have you guys seen anything with the letter I in a math class? What does the I stand for? Imaginary. So we're going to talk about these imaginary numbers later on this semester. It's okay if you've never seen it. That's all right. Okay, so at the moment that is not a real number. This guy right here, negative 64 to the half, this is really just making sure we're good on the order of operations. The question is that negative inside the radical or outside? Inside? Yeah, remember exponents are really weak and they don't reach very far. And so that 1/2 power is only applying to the 64. And so that 64 to the half we've already seen is this. And then that negative in the front is just hanging out waiting at the end of the day. Okay, so what's the final answer for this one? That one's negative 8. That's okay, right? 64 is okay, and then a negative sign at the end. Okay, number 6, same idea. It says we'll do this one in 2 different ways. So first, this is 8 to the 2/3. This one's written out, so we don't have to write anything. We'll just read. But 8 to the 2/3, where does the 3 go? It's in the front there, the little index, and the 2 is the power, right? So nothing new. Cube root of 8 squared, yeah? And then 8 squared is 64. Oh, there's a typo here, gang. Cross that off. What should it be? 3, right? It's just cube root. Sorry about that. Cube root of 64. Okay, and how much is the cube root of 64? Is 4. Okay, so the answer is 4. Nothing new. I'm going to do it in a slightly different way, and it's not going to be clear that it's legal until we get to the same answer that we got over there. So I'm going to write that cube root. So the 3 is there, just like usual, right? But then normally the 2 would be right inside there on the 8, right? But I'm going to decide to put the 2 on the outside of the whole thing, outside of the radical. Again, it's not clear that it's okay to do that, but let's try. How much is the cube root of 8? Is 2. So that's my 2 right there, and then it's still squared. And how much is 2 squared? It's 4, which is exactly the same thing we got over there. And it turns out it's totally legitimate to do that to the squared inside or outside. And so that's summarized in 7. Tyler? Yes, Irene. You don't need to. I mean, we get the same answer either way. But let me give you another example where I think it'll become clear that you'd much rather put it in one spot over the other. Let's try. Let's do a 32 here, and let's do a 3/5 power. 32 to the 3/5. Just put that in some blank space on your paper, and then rewrite that as a radical. And let's do this the normal way without this kind of new funny trick here. So where does the 5 go? 5 is on the outside, it's the index. And the 3 is right up there, yes? Okay, now 32 to the 3rd with a calculator is trivial, but on the next quest, I don't think you're going to have your calculator with you, which means 32 to the 3rd is now a big bear of a task, right? I don't really want to do 32 to the 3rd. So how about instead of doing it that way, we'll take advantage of the fact that we could have chosen to put that 3 here. Yes? That's what we're saying, is that it's okay to put the 3 inside, but it's fine to put it outside as well. And then the 5th root of 32, it's on your sheet. Anybody happen to know it? It's 2. And now we don't have to deal with taking 32 and raising it to the 3rd power. This is really 2. And it's still being cubed. And how much is 2 cubed? Is 8. So this is why we want to know that it's okay to put it inside or outside, so that we don't have to do 32 to the 3rd without our calculator. Make sense? Okay, so then number 7, Tyler. Good, thank you. Okay, so the last new thing for today is number 9. Ramses? Okay, so 16 to the negative 3/4. So again, this one's written out. We'll just read through. If I see a negative exponent, I can put 1 over, yes? So that's really 1 over 16 to the positive 3/4. That's the first step. And then 16 to the 3/4, according to what we did today, that's a radical. We know that the 4 is the index and the 3 is the power. Where did I put that 3? Inside the radical or outside? Chose to put it outside, because if you put it inside, then what calculation do you need to do? 16 to the 3rd, which I'm guessing you guys don't know. Do I know it? 4,096. Type it in. 16 to the 3rd. 16 to the 3rd. 4,096. Swish. Right. But better than that, if we don't have the calculator, is to put that 3 on the outside, right? Because then we don't need to do 16 to the 3rd. We just do the 4th root. Tyler's looking around. How did I do that? It's up. It is up. It is over there. It's also over there. but I just did it up here. Okay, but here we get to do the fourth root of 16. How much is the fourth root of 16? Fourth root of 16 is 2, and then we're just supposed to do 2 cubed, and that's an 8, but the whole time, because of that negative, it's been 1 over. So the answer here is just 1 over 8, okay? So today we have seen some exponents that are really quite a bit more complex than any that maybe you've seen before. Negatives we saw last time, but fractions are brand new for us today. Just translate them into radicals and then proceed like we did last class. Okay, the activity starts on the next page. Go ahead and get started there. Oh, let me make my announcement now before you jump into the activity. Okay, so all semester the My Math Lab homeworks have been due roughly a week after the homework has been assigned. And I set that week up sort of arbitrarily, but just to make sure that if there's some emergency and you aren't able to do the homework, like, sort of right after class or in the 2 days after class, then you won't get penalized for it. But the problem, my expectation was that people would just do the homework, like we're doing this stuff today, and that you would start working on the homework tonight or the next day or something. But I think what I've done is set up a lot of you to just do the homework on the day that it's due, which is a week removed from when you actually saw the stuff. And that means also that you aren't thinking about that material for a week, and that's not so great for seeing the next 2 classes of material, which might be based on the stuff that you've decided not to think about for a week. And so I didn't intend for that to happen, but it seems like that's what's happened for a lot of people. So starting not today, but a week from today, the new dates on the My Math Lab homework, and you can check them out. I've updated them on My Math Lab, so you'll see what the dates are. But here's the new rule of thumb to decide when homework is due. It's 2 days after the stuff was done in class, midnight of that day. So if we were starting the thing today, which we're not starting it until next week, then today's homework would be due Wednesday midnight, okay? Wednesday midnight. And the homework we do Wednesday would be due Friday midnight, and the homework we do Friday would be due Sunday midnight. Sunday midnight. So it's always 48 hours plus, well, it's 48 plus 15, 63? That's right. 63 hours after the stuff is assigned is when it is due. Again, I'm not trying to I understand things happen, and so like if something happens, some emergency, and you can't get it done until like 3 days after, just send me a quick email. It's easy for me to like counteract any of those penalties. And I'm not doing this to try to invoke more penalties. I'm doing this to try to get folks to do the homework closer to when we cover it in class. That's the goal, okay? Any questions on the new rule of thumb? Okay, so this again will start not this week, but Monday coming up. So the due dates for the 3 assignments this week are exactly what they would have been. They're due like a week later. So I'm giving you like a week to try to catch up and maybe get into the swing of this new 48-hour type thing. Okay, so activity is there. Raise a flag if I can help.